And this time I'll click on it and know what it is. So what is Apollo? In the last exercise, in the last demo, you were looking at gene models in JBrowse, and based on evidence tracks, you were trying to find out if the gene model is correct or if there's an alternative transcript. So this is something you can do in JBrowse. You can look at it. And you have to calculate, like David, does it go out of frame an exon? Will I get a valid protein? We have Apollo, where you don't have to calculate anything because it does that for you. So Apollo is based on JBrowse. It's done by the same developers that also developed JBrowse. And what Apollo does, it adds editing functions to JBrowse. And you're familiar with this view. This is the Apollo interface. And the only difference to JBrowse is that we have here this yellow area, the user-created annotations area. And this is where everything happens, where you can track up a gene model and then modify the gene model. We have also in Apollo, on the right-hand side, is an option where you can add annotation. So not only structure annotation can be done in Apollo, but you can also do function annotation. So if there has been a PubMed ID that you would like to add to a gene model, you can add that, or if there's a different gene product description, you can also add that to you in Apollo. So what is Apollo? As I said, it adds editing functions to JBrowse. It is web-based, and that means that no installation is required. And you can use it for structural and for function annotation. And the great thing about Apollo is it's collaborative. So you can get together with a group of other scientists and improve a genome. Has there been a question? No, it's gone. And improve a genome. And the great thing is the edits that someone else at a different place makes that are visible, they are visible to other annotators in real time. You don't need an extra account. You can access it using your FuPathDB account. It is available for most of the reference genomes, and Omar already explained to you what reference genomes means. These are the genomes where we map to all the data. And we currently have 461 genomes in Apollo. And if you want to know all the genomes that are in Apollo, you can see that by going to Data, Organisms, Genome Info, and Stats, which will give you a table with a column, and it tells you if your genome of interest is represented in Apollo. You can also view it, you might have seen it yesterday when we've done the gene record page exercise. You can also see that here if a genome is in Apollo. And you might have noticed that in this view, there is a track called Community Annotations from Apollo. And this track shows you if someone has made a change to a gene model, it can be viewed in this track. So for instance, this gene, it's in Toxoplasma gondii, is currently has 2 gene models, but this seems to be incorrect because we have lots of introns going on here, and someone annotated here and merged these 2 gene models into 1 gene model. So this is important information. If you work on this gene model, have a look if someone already has done some annotation in Apollo, and then you can view it here and explore it further. What you can also see on the gene record page, if someone has done a functional annotation, and here's an example. This gene here is currently annotated as hypothetical protein. Someone went in and looked at a publication and found out that this gene is now called IRD1. It was also co-terms associated with this publication, and this is searchable. So it's really important information you can add into Apollo, searchable by everyone, and it is associated with your name. So you get also credit for that. So how can you access Apollo? It's like JBrowse also here in the tools menu. And if you go there, you get to this page. And there are 2 options to access Apollo. One is for experienced users. So if you already know how to use Apollo, you can go there, and this interacts with the live site. So whatever changes you are doing there, that will show up on the gene record page. Or we have this here for new users, our sandbox. So you can play around here. It's the same Apollo instance as the live one, but it's just for playing around, for trying to get familiar with Apollo. Nothing is being kept there, and so you can just try around and see if you like Apollo and work on it.
So if you'd like to play around with this and help in improving the annotation of your favorite genome, but are afraid that you don't want to screw things up, feel free to use the sandbox. Nothing kept, you won't mess things up for anyone else.
Thanks, David. Yes. And the same site also has some additional information if you want to learn more about Apollo. It has FAQs, a tutorial channel. So have a look at it if you are interested in Apollo and in improving genome annotation. And with that, I'm now going to fix the gene model that we've looked at, that David looked at during the exercise. Okay, so to access Apollo, you can go here to Apollo. And I'm going to use here the sandbox. For the sake of time, I've already opened it. It's here. And you might recognize this gene. It's the protein phosphatase that we've discussed in the demo at length, and noticed, I put on labels, that there is a very valid exon skip. So how can you fix that? And you will see it's really, really easy. What I want to do is first put on some tracks. So you can see here different tabs. There's an annotation tab which shows you that there has been already some annotation done on this genome. But there's also a tracks tab. And one of the most important tracks here in Apollo are these trackable annotation tracks. I'm going to add the track called annotated transcripts. And it's just the same transcript. And you might notice now there are different colors. Apollo shows the different frames in different colors. You can zoom in actually. That's another difference to JBrowse. You don't need a track called reference sequence because you can just zoom in and see the sequence. That's really important as an annotator. You always want to have a look at the sequence. And then you can see here, this exon is red because it's on this one here. This is the sequence. So you can associate the exons with the sequence. Okay, so I've added the annotated transcripts. What I also want to add is the introns that match the annotation. It's the same as this one here. I can also add the labels. You can see here, it's the same. And I'm going to add this, the introns number with strong evidence. So these are not considered in the current annotation. And to make things clearer, I'm going to get rid of these two tracks. So let's add the isoform. What you need to do is you need to select the gene, and you can do that by clicking on the intron, and then you get a red border, and then you just drag it up into the user-created annotations area. To create an isoform, you just need to duplicate it, and you can do that by clicking on the gene in this user-created annotations area, and then duplicate it. And then we've decided that there is an exon skip. This is this intron here. And you can actually click on these introns, and then you can see here with the red border where they are. And it clearly says this exon needs to be deleted here. So let's delete it. And let's see what comes out the other end. And as David already said in his demo, we will get a much shorter CDS, but probably valid. This has now a longer UTR, but here a much shorter CDS. To finalize the annotation, what you need to do is go again and click on the gene and say Open Annotation. And then you get here to this annotation editor that I've showed you before. And you just need to select the status as finished. And that's all. You can always put on comments, say why you've added this isoform. You can also add additional a gene product description. Maybe this isoform is mentioned in the publication, and then you can also add here a publication. And that's all. And maybe just one more thing, just to show you, it's not just only easy to delete exons. It's also very, very easy to modify exons or modify UTRs. You just need to click on the exon or the UTR. You can see there is now a border, and then hover at the edge until you can see this little arrow, and then you can modify it. Make it longer or shorter. Yeah, I think that's all I wanted to say to Apollo. We do have an optional exercise where we provide you with a list of genes from some of our genomes that we have in TruePath-DB. You can also use the search that David showed you, the unannotated intron junction search, to find incorrect gene models, and then just play around with a gene in Apollo. And just one more point to the optional Apollo exercise. It gives you a list of things that can be wrong with the gene models and explains you step by step what you need to do in order to fix it.